Section 1.2, graph quadratic functions in vertex or intercept form. First we need to identify vertex form of a quadratic equation, and it looks like this. Y equals a times the quantity x minus h squared plus k, where hk is the vertex of our parabola, and the a value is the same as the a that was in front of the x squared term in standard form. So it tells us if the parabola is going to open up or if it's going to open down, and by how much. Is it going to be taller and skinnier, or is it going to be shorter and wider? So those are the bits of information that we have. Alright, so what do we need to do to graph a quadratic in this form? So here's our equation of a quadratic. Identify the parts. We know that a is equal to 1/4. The negative tells us that it's going to open down instead of opening up. Our h value is going to be equal to -2. And the reason it's not 2 is because, remember, it's minus h. So whatever h is, we're taking the negative of that. So in order to get a positive 2, h would have to be -2, because negative of -2 equals a positive 2. So the h value will always be the opposite sign of what's in there. And then of course our k value is just 6, and it's whatever the sign is. Since it's a +6, it's going to be positive. If it was a -6, then this would be a -6. Okay, so that's the first step. We need to identify those things. The second step then is to plot what we know. So let's go ahead and plot our h and k. Remember, that represents our vertex. So h is like the x value, and k is like the y value of our vertex. So our x is -2, 6. So we know our vertex is at -2, 6. And like I mentioned before, since our a out here had a negative in front of it, we know this thing's going to open down. Okay, so after we've plotted that, we need to draw the axis of symmetry. And we know the axis of symmetry then is going to go through our vertex. And it's going to have the same x value. X equals the same x value as our vertex did. Remember, it was -2, 6. Okay, so we have an axis of symmetry. Now we need to come up with some points. If we know 2 more points, one on either side of this, then we can draw this thing. Maybe the easiest one to find would be where this thing's going to cross the y-axis, or find the y-intercept. And we know that it's going to cross the y-axis when x is equal to 0. So we're going to put a 0 into our original equation here. For x. And we're going to work this out. And it's going to equal 4. So we know y is going to equal 4 when x is 0. So 0, 1, 2, 3, 4 has to be on that parabola. And because of our line of symmetry here, we know that this point was 1, 2 places that way. So we know we're going to have another point that's 1, 2 places this way. So we're going to have a point at 0, 4, and have a point at -4, 4. Once we have those, then we can go ahead and graph our parabola, and it's going to look like that. Second part of this section has to do with intercept form of a quadratic. And the intercept form looks like this. Y equals a times quantity x minus p times quantity x minus q. In other words, it's in factored form. Okay? The a is still the same as the a in front of the x squared term in our standard form of this equation. And our p and q determine the x-intercepts, or where the parabola is going to cross the x-axis. Those are called the x-intercepts. So in order to graph this, first we want to identify the x-intercepts, which are p and q. So we know it's going to cross the x-axis at p0 and q0. So we have those 2 points. Then we need to find the axis of symmetry, which is halfway between these 2 points. And to do that, then, it's very simple. The axis of symmetry we're going to take the x value of that is going to equal our p plus our q, and we're going to divide it by 2. In other words, we're finding the midpoint between these 2 points right here. So to find the midpoint, the formula is p plus q divided by 2. And that'll give us our axis of symmetry, which will also give us the x value of the vertex. Once we know the x value of the vertex, then we can find the y value using our the original equation. And once we have that, we can plot all those points and then draw our parabola. So let's look at an example. So y equals 2 times x plus 3 times x minus 1. Okay, so we know our a value is equal to 2. So we know this parabola is going to open up, and it's going to be a little narrower than what the parent function would be. We know our p value is going to be -3. So remember, looking back at our original here, if p is -3, the negative of -3 is a +3. We need to have a positive. So these are always going to be the opposite. So if it's a +3, then it's going to be a -3 is what. So our q then is going to work the same way. Since this is a -1, then q has to equal a +1. Because in order, if q is +1, the negative in front of it will make it a -1, which is what it is there. Alright, so now we can determine our x-intercepts. So we know one of them is going to be at -3, 0. And the other one's going to be at 1, 0. Now to find the axis of symmetry, we're going to take p, which is -3, plus q, is 1, and divide it by 2. So this equals -2 over 2, which is -1. So x equals -1 is our axis of symmetry, which would put it right here. So we know our vertex is going to be on that axis of symmetry. We have the x value of it, but we still need to determine the y value. So to get the y value on this axis of symmetry, to get the vertex, we're going to take the -1, put it into our original equation, and determine what y has to be. So y is going to equal 2 times -1 plus 3 times -1 minus 1. And if we work all that out, it's going to equal -8. So we know our vertex is going to be at -1, -8. And we knew it had to be below these 2 points because this thing's going to open up. So the vertex has, and if it's going to go through these 2 points, it has to be below it. And that's what's going to get us below there, it's at negative 8. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So now we have our vertex. We have 2 points that we know this parabola will go through. So we can draw our parabola. And that's how you would draw the parabola from intercept form. Okay, the last thing they talk about here is in this section is changing forms of an equation. The first change is changing from intercept form to standard form. Okay, so let's write an equation in intercept form. All right, and in order to do this, notice we have 2 binomials multiplied together and then that times the negative 2 out in front. To multiply 2 binomials together, we're going to use FOIL. Remember, FOIL stands for first, outside, inside, and last. So we're going to leave the negative 2 out in front. At this point, we're going to multiply these 2 together. So we're going to start out with the first 2 terms, which would be x times x, which is x squared. Then we're going to do the outside 2. That would be this one and this one. So that would be negative 8x. Then the inside 2 would be the 5 and the x, be a positive 5x, and then the last would be 5 times negative 8, which is negative 40. We can combine these 2 because they're like terms. So y equals negative 2 times x squared minus 3x minus 40. Now we have to distribute the negative 2, so we're just going to multiply everything inside here, the equation, or the parentheses, times the negative 2. So negative 2 times x squared, negative 2x squared, negative 2 times negative 3 is a positive 6x, and negative 2 times negative 40 would be a positive 80. So this would be the equation in standard form of our from our intercept form. The other way is changing from vertex form to standard form. So our example, I have this written in function notation this time. F of x equals 4 times quantity x minus 1 squared plus 9. So remember, our order of operations, we have to do exponents before we can do multiplication or addition. So we're going to have to multiply the x minus 1 times x minus 1. Do that part first, and then we can take that answer times the 4. And then we can add the 9 at the end. So we're going to use FOIL again to multiply these. So we have first, outside, inside, and last. Combine these 2 together. Minus 2x plus 1 plus 9. Now we do multiplication, so we have to distribute the 4. This is 4x squared minus 8x plus 4. Now we don't need the parentheses anymore. We still have the plus 9. Now the only like term is the 4 and the 9. So we end up with 4x squared minus 8x plus 13. And that would be our equation in standard form from our original vertex form.